guys ready to have a great time this afternoon? Okay, welcome. Thank you all for being here at our EPYC Horizon event. I am so excited, and on behalf of all of AMD today, we are so excited to spend the afternoon exploring the solutions of the new modern data center. You know, many of you were actually with us a couple of years ago in 2017 when we introduced Naples. And we said that we are making a huge commitment to the data center, and we meant it. So we've done a lot over the last couple of years, and I'm really excited about everything that we've done. But today is a next huge step in that journey as we talk about the next generation. So let's just spend a minute of background, right? You guys know all of this. You know, if you look at where we are today, you know, data is at the center of our universe. We have an incredible explosion of data in all kinds of applications, in all kinds of workloads, and all of this data requires more compute, more horsepower, more storage, more ability to process, more ability to take action on all of that data. And there are a tremendous number of workloads. It's not a one-size-fits-all. And as a result, you really have to have the best system out there. And whether you're talking about high-performance computing, or you're talking about cloud environments, or you're talking about machine learning, or big data, every single one of these workloads requires more compute. And every single one of these workloads requires better data centers. And that's what we're all about. That's what we're here to talk about today. So let's just take a moment and take a step back and say what's important in the data center. The truth is, if you're operating a data center today, you are under immense pressure, okay? Everybody wants more. You want more performance. You want lower total cost of ownership. You want extreme scalability. So you might build your data center today for a certain set of workloads, but frankly, 3 years from now, it might be a different set of workloads. You might have a different mix. And you need that scalability and flexibility. And then, of course, the last piece of it, and we now hear about this every single day, is security. Security is the foundation. We must offer our customers, our users, the entire ecosystem, a secure environment. And that has to be designed in from the ground up. And we've all learned that. So, if you take a look at all of this, what does it mean for us? It means that the modern data center actually requires a ton of new thinking. We've got to think differently. And frankly, that's exactly what we believed at AMD. We believed 5 years ago, when we started on this journey for the next generation data center, that you couldn't just do one thing. It's not about just the chip. It's not about just the processor. It's about how do you put all of those things together? How do you really think about it in totality? And so that required, certainly, we developed an all-new CPU and GPU architecture. We're going to talk a lot about the basic foundation. We also needed to develop very aggressive roadmaps. So the fact of the matter is, you can't get it all done in one generation. You can't, because you learn. Every single time we go into an environment with a customer, we learn, and we get better, and we put that into the next generation. And we think about it as a system approach, okay? We've all talked about Moore's Law. Moore's Law is not dead, but Moore's Law is changing. And what that means is that we need a different approach to our chips, a different approach to our systems, a different approach to how we put things together. And then the last point, which I want to make, which is extraordinarily important, is we completely believe in an open ecosystem. An open ecosystem allows the best of the best in the industry to come together and innovate together. And frankly, I am so happy to see so many of our ecosystem friends in the audience today, because you guys really make us better, and we make the industry better. So thank you for all of that support. Now, just a tad bit of history, just a tad. In our world, years are not long. We launched the first generation of EPYC, we called it Naples, in 2017. And it was an ambitious effort. It was an ambitious effort. It was our first server sort of generation with our new Zen architecture. We had 52+% IPC improvement. More importantly, we wanted to bring something new to the data center. So we said, let's do something different. We need more cores. We need more memory. We need more I/O. We need that to be performance leadership at every price point. And we need to ensure that total cost of ownership is better. And so we did a lot around the single socket server and how that could change the economics of the ecosystem. And that was really significant work for us over the last couple of years. And if you take a look at it, as I said, the ecosystem has been phenomenal. We are so proud of the ecosystem partners. If you take a look at the OEMs, the ODMs, the hardware partners, the software partners, all of these folks that have come together in the EPYC ecosystem, we can't be happier with how the first generation has gone. And we have over 60 platforms in market today. And that number is growing every day with new customers adopting first generation EPYC. Now, there's also a tremendous amount of excitement around the cloud environments. You're going to hear a lot about cloud, how cloud has changed the data center, has changed the way we think about the data center. And if you look at some of the largest cloud environments that are using EPYC, they include the most important ones like Microsoft and Amazon and Tencent and Baidu and many others. And all together, if you look over the last 18 months or so, we have more than 50 EPYC cloud instances available today across major hyperscalers, as well as many of the next wave cloud environments. And that number actually continues to grow every single month. The reach of EPYC is continuing to grow, whether you're talking about across instance types or across regions. There's a tremendous amount of activity going on. The value proposition is key. The value proposition is key. So what is our value proposition? Our value proposition in these cloud environments is really clear. We want to offer better performance, lower costs, more flexibility. And to just give you an idea of how that has gone in the first generation of EPYC, let me just show you a short video from Amazon on their progress with EPYC.
One of Amazon's leadership principles that we have is customer obsession. We listen to the customer and innovate on their behalf. This is one of the reasons that AWS has been able to build the most reliable global cloud infrastructure with the broadest and deepest portfolio of services. Millions of customers, from enterprises to startups, are building their businesses with AWS today. As a result, more workloads, including SAP, high-performance computing, machine learning, Windows, and many more, run on AWS, more than any other cloud. Customer obsession is also why we continue to add more EC2 instances to help balance the cost and performance of our customers' workloads. Last year, with AMD, we announced our partnership to offer EPYC-based Amazon EC2 instances. These instances were initially in our general-purpose M5 and memory-optimized R5 families. One specific customer example is Expedia, a leading online travel company. Expedia adopted EPYC-based EC2 instances for many of their microservices applications. Expedia easily deployed the EPYC-based instances due to the application compatibility, familiar instance sizes, and they were able to reduce their cost by 10% in the process. We now have 5 EPYC-based instances spanning more than 15 global regions in North America, Europe, Asia Pacific, and GovCloud. Moving forward, we're excited about the next generation AMD EPYC processor. The second generation EPYC processors will be a great fit for many workloads that our customers run in the cloud today, and will continue to offer them compelling economics. As we build the next generation instances together, we're anxious to see how our customers will use the technology. The future is exciting, and we look forward to continued collaboration with AMD. Thanks a lot.
All right, so that gives you just a flavor. AWS introduced their first EC2 instances with AMD in November of last year. So it's really been phenomenal to see what we've accomplished over the last 7 to 8 months with our joint customers. And we really look forward to really offering much more capability through the cloud environments. But as exciting as first generation is, we are even more excited about the second generation of EPYC. And when you look at what it takes to really have a long-term roadmap, let me just give you a little bit of background. You guys have heard me talk about this because this is the same way we feel about our PC roadmap and our gaming roadmap, and today our server roadmap. As a company, to build high-performance products, you must bet big. You must decide 3 to 5 years in advance, what are you going to bet on? What are the technology trends that are going to be important? And how do we make sure that we are at the leading edge of those technology trends? And frankly, that is nowhere bigger than it is in the server environment. So 3 key things. A big bet on 7nm process technology. You'll notice, by the way, today is August 7th. 7 has some meaning for AMD this year. When you look at that, we take 7nm process technology. We have a very, very strong foundation in our differentiation around high-performance cores. So that's high-performance CPUs, and that's high-performance GPUs. And then we really bet on a chiplet architecture. We had a first-generation chiplet architecture with first-generation EPYC, and we've migrated that to a much more advanced chiplet architecture here in the second generation of EPYC. And that's really to give us optimized performance. So we're using the right technology for the right reasons in this generation. And I'm proud to say that for the data center, those bets really, really paid off. And they're the foundation of all that we're going to show you today in terms of the second generation of EPYC and how we bring that all together. So let me get started and tell you a little bit about Rome, our second generation EPYC processor. So today, I can proudly say that the second generation EPYC is the highest performance x86 processor in the world. And it comes with incredible performance. And we are going to spend the next 90 minutes showing you performance benchmark after performance benchmark, workload after workload. We're going to show you 80 world records today because that's what we've built with Rome. It comes with a brand new architecture. You're going to hear a lot about the architecture from Marc Papermaster in a short while. He's going to tell you how we brought the Zen 2 cores, how those cores are completely optimized for server workloads, how we optimize our new Infinity Fabric, how that comes together with our chiplet design. And when you put all of that together, what you're going to hear from Forrest is why it matters in the data center environment. It's all about data center total cost of ownership. Our goal is to make the data centers of today and tomorrow substantially better than they were yesterday. And what I hope you walk away with at the end of this afternoon, what I hope we prove to you, is that if you are building a data center today, if you are upgrading your data center, if you're doing anything in your data center, you should be doing it with EPYC. You should be doing it with EPYC because it is the new benchmark. It is going to be the new standard for the modern data center. And I'll ask you at the end whether we have actually done that. So, just one page on speeds and feeds. I promise, just one. When you look at the specs of EPYC, look, we put everything in it, okay? We have the most cores ever in an x86 processor. 64 cores, 128 threads. And these are very powerful cores. You will see that in the IPC results that Marc shows you. We also said, look, it's not just about the processor, it's about how you put the processor into the system. And so we have the most I/O ever on an x86 processor. We have the ability to access 128 lanes or higher of PCIe Gen 4. We are the first in the server CPU market to offer PCIe Gen 4. Why is that important? Because frankly, your processor needs to connect to your storage, to your memory, to your accelerators. You need it at the highest possible bandwidth, and that's why we leaned in here, and we leaned in with our partners. And when you put that into 7nm technology, what happens is you take a given power envelope, let's call it 225 watts or so, and you're able to get tremendous density. That's how we get 64 cores. And you also get tremendous speed. And that's why our boost frequencies go up to 3.4 gigahertz. So that's the power of the second generation EPYC processor. Now I want to spend a moment to put that into context, because everybody comes to every launch event and says theirs is the best, right? Is that what we all do? But you really have to put it in context, all right? What I'm showing you here is historical data center performance. So this is spec and rate, a good throughput benchmark. And this is the last 5 years of the industry standard. One on this in 2015 is the Haswell processor from our competitor. And as you can see, over the last 5 years, the CAGR has been somewhere between 15 to 20%. Some years it's a little bit less, some years it's a little bit more, but it averages out to 15 to 20%. What we call this is incremental improvement. It's incremental improvement. So we said it's going to take us a few generations, but we are not going to give the data center incremental improvement. We're going to change the game in the data center. So 2017, we launched Naples. We launched the first generation of EPYC. It was a very competitive part. And if you take a look at it in terms of the number of cores, the number of threads, the number of I/O, particularly in single socket configurations, particularly in some HPC workloads, it did very, very well. And we saw good performance. And we saw good adoption, as you saw in the last few minutes. But we knew we could do more. I said earlier that we learn from every single interaction. We learn every single day, and we knew that we could do better. And we continued this vision of innovation above the curve. I like to tell people we're bending the curve, or we're drawing a new curve, but that's our ambition at AMD. We don't want to stay on the industry standard curve, because that is not differentiating for us. So, here you have it. Now, when you go to the second generation of EPYC, you can see what drawing a new curve means. We have created a new industry curve. The second generation of EPYC, and we're going to show you in plenty of gory detail, increases performance by 2x compared to today's industry standard. What we're calling industry standard in 2019 is our competitor's Cascade Lake processor roadmap. It is something that the competition just introduced a few months ago, and we are almost double of their performance. And that's what we call changing the game. Okay, so let's take now performance of a processor and talk about it in the context of workloads, right? We are here to solve the world's toughest problems. We are here to change the game in the data center, and that requires performance on the most important workloads. And so what we're going to show you is across cloud, across HPC, and across enterprise, frankly, nearly every workload will benefit from second-gen EPYC. And that is truly our goal. So let me start with just a few numbers, and it'll just give you an idea of the performance that we're talking about. So starting first in the cloud, what we're now comparing, this is a dual socket compare. This is now comparing the top of the stack EPYC processor Forrest is going to go through the entire stack in a short while. I'm just talking top of the stack. The top of the stack we call EPYC 7742, the 7742. It's the 64-core processor. It's at the highest boost frequency. And we're comparing it to the top of the stack of the Cascade Lake lineup. So Intel's Platinum 8280L processor. And what we're showing is its peak spec-it rate. We're showing 97% higher performance. That's 97% higher performance, and what that translates into is tremendous throughput capability, okay? And that means it gives us more containers, it gives us more virtual machines, it gives us more performance on workloads like search and newsfeed, which are really important in the cloud environment. And all of that translates into tremendous TCO benefit. So that's where we are on the cloud workloads. Now let's take a look at HPC. You have seen a whole lineup of HPC partners line up around second-gen EPYC. Frankly, before many of them have seen silicon. And you ask yourself, why? Why? We put a tremendous amount of effort into the floating point unit for Zen 2. Marc will show you 4x the floating point of Zen 1. You like that? But look, it's a total system, right? So floating point is the most important thing in HPC. When you look at spec rate float, again, comparing top of the line EPYC to top of the line Cascade Lake, we see 88% higher performance in these workloads. And what that really translates to is all of our extra cores and all of our floating point capabilities allows us to do much faster simulations. You can get a lot more done on AMD EPYC systems. And frankly, all of our I/O and memory bandwidth, we can operate on much larger data sets. And so when you talk about solving tough problems, these are the types of things that you need in your overall system. So finally, I'd like to talk a little bit about the enterprise. You know, the enterprise is a very, very interesting place because there are so many workloads. There are a diverse set of workloads, whether you're talking about legacy applications or new applications and how you put all of that together. But the truth is, when your underlying foundation is good, you make a tremendous impact in enterprise workloads. And so there are a number of things that we can show you, but this is just one example. This is showing a spec JDB benchmark, which is a good proxy for anything that requires Java performance. And once again, what we're comparing here is top of the line EPYC to top of the line Cascade Lake. And we see 84% higher performance than the competition. And what you're seeing is the processor capability for enterprise workloads, because we have those 64 cores per socket, because we get more than double the VM density, because we have that additional memory bandwidth, it gives us tremendous capability, including world records in database performance that I think you're going to be very, very excited with. So there are many things that we can show you. Now you know that server-type demos are better with some time. And so I hope you will have a chance to visit our transformation zone, which is right outside of the theater, because we have a number of real-world head-to-head demos. You'll see dual-socket performance across a number of workloads, again, comparing top-of-stack EPYC to top-of-stack Cascade Lake. You'll see finite element analysis, fluid dynamics, some container applications, some popular database stuff. And what you see is across a broad variety of workloads, you'll see 1.5x to 2x performance. So really, really exceptional performance. Now, I hope you've gotten a little bit of a flavor of what we're trying to accomplish with second generation EPYC. We are really here throughout the afternoon to prove it to you. And like I said, we will show you proof point after proof point of our value proposition. But when we say 1.8 to 2x the performance of our competition, we mean it. We mean it. When you take a look at how we're positioning the stack, and Forrest will go through that in a little while, What we're saying is we're going to offer you exceptional performance for a good price. And what does that mean? That means on many, many cases, we're talking about 2x performance per dollar, even going up close to 4x when you get to the top of the stack. And then when you look at all of this capability, it gives you the opportunity for lower OpEx as well as lower CapEx. And the most important thing that we're going to come back with each time is, what does it mean for the data center operator? We are not talking about theoretical benchmarks. We're not talking about theoretical performance uplifts. We're talking about real-world applications where you see 25 to 50% improvement in total cost of ownership, just by going to second-generation EPYC. So we think that's a phenomenal value proposition, and one that will keep coming as the key to our message. So now let me talk a little bit about how you deliver all this, okay? I said earlier, you can't do it alone. This is not a personal sport. The ecosystem is incredibly important. And the ecosystem is today here in full force. We believe that with our OEMs, our ODMs, our hardware partners, our software partners, that we have something truly special with second-gen EPYC. You can't accomplish the first processor with PCI Gen 4 if you're not working really closely with the ecosystem. The thing that is even better in second-gen EPYC than the first-gen is we co-developed with our partners. We co-developed in parallel, so we would have, once the silicon was ready, we would have the ecosystem ready with us also on day one. And I'm happy to report today, you're going to see a number of systems that are available today or very shortly. And we have over double the number of platforms that will be available on second-gen EPYC compared to the first-gen EPYC. And you'll see the breadth of the platforms that we're talking about. So I'm really excited by that as well. So as we do this, I want you to hear directly from some of our customers and partners. And so with that, for our very, very first guest of the day, I would like to invite Marc Potter from HP Enterprise, who is the Chief Technology Officer, to the stage to talk about HPE. Marc?
I'm doing well. August 7th, big day.
Marc, it is great to have you here. Thank you so much for being here. You've been with us, though, since day one. I mean, you guys have been there since the beginning.
You know, I remember 5 years ago, we were sitting together talking about making a big move in the data center. And talking about bringing the two companies together and what exactly could we do to take that big step. And then 2 years ago, Antonio Neri, our CEO, and you were on stage launching the first generation of EPYC.
Yes.
And Antonio at that time said, Hewlett-Packard Enterprise is all in. This is a strategic partnership, and we've been working a lot. So today, August 7th, 7 nanometer, I love that, is a culmination of a lot of hard work and collaboration by the teams.
Well, look, we can't thank HP enough. I mean, you guys have been phenomenal with our engineering team. Now, we've done so much together on first-gen EPYC, but Marc, the guys really want to know what we're doing on second-gen EPYC.
Yeah, I figured you guys did. I will just say we've been busy, very, very busy. We have been developing with your teams a full portfolio of highly workload optimized systems. Lisa, you talked a lot about it matters, performance, and TCO. We've been busy from, I would say, leadership, high performance computing systems to deal with the biggest, baddest workloads in modeling and simulation, big as in big data analytics, as well as AI ML, as well as leadership database systems, analytics systems, virtualization leadership platforms across the board. And I'm super pleased to announce today we have 3 systems available.
By the way, can I say that again?
Yes.
Available today, Marc?
Available today. We're announcing, yes. We're announcing the DL325, the DL385, and the Apollo 35. And we're just getting started on that. By this time next year, we will have 12 workload optimized systems based on EPYC 2 in our portfolio. How awesome is that?
That is fantastic. That is fantastic. Look, our engineers love working with your teams. You guys are really, really incredibly capable. Can you tell us a little bit about the performance you're seeing on Rome?
Yeah, I'd love to. We've been really tightly collaborating, and we bring decades of system knowledge. We're one of the few system companies that still have that deep silicon expertise and chipsets and I/O and fabrics, and we brought that to bear in partnership with Marc Papermaster and Forrest and team, and I'll tell you, remarkable. We have special technology as well that we put in called workload matching, and what we do with workload matching is we've taken all that knowledge and we automate the system performance to maximize the performance of these different workloads. And I'll tell you, remarkable. The teams together in these platforms, 37 new world records. Is that amazing?
We like 37 records.
And these are world records against the fastest, best performance that was existing until we came and brought that workload matching in our teams in collaboration with these optimized systems. And I want to kind of share a little bit because I think it's important. You talked about virtualization. It is a workload that 80% of our customers run across the board, leadership in virtualization in these systems, 62% faster performance, 30% lower energy. That's important. Database. Customers are wanting to consolidate database with virtualization, 3 times the performance, 30% lower TCO, and then data analytics, over 38% faster performance. And so we're just getting started. And I think about the partnership and where we're going. I'm just super excited.
I think it's phenomenal. And when you think about also some of the customers that we have that have already adopted 2nd Gen EPYC, it's just really a great thing.
Yeah, and so I think also about some customers that we have, 2 that are in the high-performance computing space. The University of Minnesota with the Minnesota Supercomputing Institute, their example is fantastic. They're already taking advantage of this capability today, building. And what's really interesting about them, you talked about how EPYC Generation 2 has really taken big steps forward. They're trying to create a 20,000 core supercomputer that's really ready for any workload that comes from not only the system, the university system, but for the whole state. And so they really needed something that could deal with diverse workloads in a good way. And so that workload matching is important. And then the other great customer example I want to share is the Supercomputing Center at the University of Stuttgart called HLRS. They are building a 24 petaflop, that's 1,000 trillion floating point operations per second, 5,000 node system to deal with the biggest, baddest workloads there are. And so both those really, really important. The EPYC capability that Marc will share later, our workload matching and optimization along with those platforms. And so I would say we've been super busy.
We've been a little bit busy.
Yeah,
just a little bit busy. But look, we all know performance is really important. We also know that security is top of mind for everybody, and HPE is really a leader in security. So can you talk a little bit about your security strategy?
Yeah, a couple years ago, actually about 3 or 4 years ago, we really took a step back and we thought differently about security. We really took a philosophy of a zero trust design model, meaning we had to think about security in all aspects. At the same time, while we were doing this, we continued to see different attack vectors coming into systems, attacking the BIOS, attacking the BMC. And so with this mindset of zero trust, we knew that we couldn't just kind of add security on after the fact. We had to build it in. So 2 years ago, we launched what the industry agrees with as the world's most secure industry standard server. And we added a lot of capability there. We added the latest Cypher algorithm, CNSA 256, to our remote interface. We added enterprise key management built in to the BMC so that we could link and allow customers to encrypt data at rest easily across our entire enterprise. And finally, and very importantly, we added an immutable silicon root of trust into these systems. So we knew exactly where they were built, and we knew that when that code booted up, the very first instructions executing, we could authenticate and ensure this system was secure. And I'm pleased to say, through collaboration with Marc and team, we've linked that to the EPYC secure processor, and we now have taken a major step, taken already the most secure system and making it even more secure. Foundation's super important here. Because if we can't secure the base system, it doesn't matter what the OS does later. And so, very important collaboration, and we're going to keep building on this because we're using it to secure the supply chain, as well as we think about the distributed world we're headed to, we're going to be able to secure the workloads and the systems together in this world where we're growing edge to data center.
No, look, it's absolutely fundamental. We completely agree with you, and frankly, I think all of us are just putting more resources into security. But in addition to security, I mean, look, these data centers are getting really, really complicated. Can you talk a little bit about how HPE addresses that and helps customers with operations and manageability?
Yeah, it starts with automation. I just talked about the fact that data is growing everywhere, and we're distributing these great compute solutions further and further out to kind of act on that data at the edge. And we really think the key to that is about automation and artificial intelligent operations. And we have proven world-class technology with InfoSight, and we have really taken InfoSight and thought about how do we use that AI ops technology to help systems self-manage, self-heal, self-govern, and optimize. But we've taken years of information looking at application patterns, and we've looked at hundreds of thousands of systems and over 1.25 trillion data points to help our customers really predict failures, prevent failures, and self-optimize, self-heal. And I'm very, very pleased to announce that our full line of AMD EPYC solutions will be supported by the industry's leading AI ops platform, InfoSight. Is that a big deal?
Mark, absolutely fantastic. I love it. We like technology, but you and I also like to sell servers and put them in people's hands. So can you talk a little? Yeah, just a little bit of that. So can you talk a little bit about how people can get access to second-gen EPYC?
Yeah, well, first I want to invite all of you to visit us out in the partner zone and come see the systems and talk to the team. They are available today. I talked about that. But I think, I want to summarize. Look, we've been spending a lot of time working with you in collaboration. Not only do we have a leading portfolio of products optimized for different workloads, growing to 12, some available today, but we've surrounded that with leadership performance and embedded the world's best security, which I think is important. And we've also allowed these systems to be managed in an automated way with a world-class proven AI ops engine. But I think finally is we're delivering these systems the way our customers want. And so they can order it in the traditional way through our worldwide channel partners and buy a traditional method, or we're also making these available through our leading GreenLake as a service, so you can pay per use as well as kind of be able to deploy faster. And so customers using GreenLake and our pay per use as a service offering actually save close to 30% on infrastructure costs and typically can deploy a third faster than traditional. And so we're going to deliver these the way customers want, both traditionally as well as through our multi-billion-dollar GreenLake as a service offering.
That is absolutely fantastic, Mark. I have to say, on behalf of the entire AMD team, we are so proud and pleased with the partnership. Please thank the entire HPE team, and let's go put Rome in the hands of all of our customers as soon as possible.
That's our plan. Thank you.
Thank you very much.
Collaboration. All right.
All right, so there you have it. HP Enterprise, 3X portfolio, 37 world records, 3 systems available to order today, and clear leadership across enterprise and HPC applications. Now, let's move to the other end of the spectrum and look at the cloud environment. When you look at the cloud environment, there's been just incredible growth over the last few years, and we know we're part of it. Frankly, we're part of how we're using the cloud environment. And these environments have incredibly demanding workloads, and they really stress the hardware and stress the system overall. And so when you think about it, the cloud guys are often the first to adopt great technology. So for my next guest, I'd like to welcome Jen Fraser from Twitter to the stage to talk about their environment. Jen? How are you, Jen?
Doing well, thank you.
Oh, thank you so much for being here. We're really honored to have you here.
It's great to be here.
Jen, I am personally a huge fan of Twitter. Do you guys know that? I'm sort of a huge fan of Twitter. And I'm just amazed at how much traffic goes through Twitter on a daily basis. You know, you must have an incredibly tough job with your hardware infrastructure. Can you talk a little bit about what goes on in Twitter's data centers?
Yes, absolutely. So our data centers actually process hundreds of millions of tweets on a daily basis. And those tweets actually generate trillions of instances that our platform has to manage. We focus on performance and user experience, and that requires us to update the underlying technologies. We're also really intent on power efficiency, which is not only good for our business, it's also good for the public conversation that we serve. That's why we're so excited about the EPYC processors.
Well, look, I have tremendous respect for everything that you're doing at Twitter. And frankly, if it's down for a second, people notice.
Yeah.
But, you know, look, I talked earlier about just the tremendous pressure that data centers are under, right? You're trying to satisfy so many people with so many demands. Can you talk a little bit about how Twitter's scaling up for all of the new demands in the data center?
Absolutely. So Twitter's data centers this is where Rome actually is like hitting that sweet spot for Twitter's data centers. The performance that we're seeing on the Rome processors are actually reducing the amount of power consumed per core, which is allowing us to scale within our existing data centers.
Can you show us a little bit of what that looks like?
Yes. Once you're running at scale, you really start to focus on maximizing the amount of work that you can get done in each rack footprint. If we can run more jobs in the same amount of space and power, that means significant operational savings. With Rome's ability to give us 64 cores and 180 watts of power, we're able to put 40% more cores in each rack.
You know, and your environment is, very constrained. You know, the same power envelope, same cooling. What does that mean in terms of total cost of ownership when you see Rome in the Twitter environment?
So that's where we're really excited. With Rome, we're able to get a 25% reduction in the TCO, or total cost of ownership. And we're getting this by seeing the same, or an increased number of cores in the same footprint, which is reducing power while using the same amount of cooling in the data centers. So we're actually growing within the same envelopes.
No, it's really exciting. And can you tell us just a hint about when Rome will be in production?
It will be in production into Twitter's data centers in 2019, and we are so excited about that.
Is that exciting or what, guys? Look, Jen, I really want to thank the entire Twitter team. You guys have really been at the leading edge. You know, when we talked originally about bringing Rome to Twitter, we knew it'd be a lot of work. You know, we knew that you guys had to get to know us, we had to get to know you. But the teamwork has been just great, and I just can't wait to have Twitter up and running with Rome. So can we do something fun to celebrate our launch?
Absolutely.
All right, guys, what do you think about helping us increase my Twitter followers? Did I say that? Yeah, I think I said that. Why don't we take a selfie with the audience before you leave, huh?
Absolutely.
You're going to help us with that. All right, audience.
Sorry.
That looks really good.
Sorry, I got a video of you guys. Ready? 1, 2, 3.
Fantastic, fantastic.
Thank you so much. Congratulations, and we look forward to production this year.
Thank you, thank you. That was completely exciting. I really love to see new technology in action, and truly they have one of the most demanding environments that we've encountered. So, look, I hope you got a good overview in this first section of what we set out to do with Rome and how our partners and customers are using Rome. But now let me turn it over to Marc Papermaster, our CTO, the guy who really did all of the deep technology on Rome with him and his team. And he'll tell you about our cores and the technology and everything under the covers. So Marc?
Well, I just got to say, it's such a fantastic day for us here at AMD, because this is a milestone. We've been working for years, driving back to high performance, and here we are today in a leadership position. 80 world records announced today. Simply fantastic, and thank you for being with us here today. Well, I'll tell you, I have to start by talking about our journey. because, we were, from the get-go, as we launched our focused effort at AMD about getting back to high performance, and that's what Zen was all about. It was about that 52% generational IPC leap as we launched Zen. And, I remember that at that time, right, as we went through the roadmap, talking to our customers, talking to the press and analysts, and reminding them that for us at AMD, it's about the roadmap. It's about focused execution. And so I couldn't be more pleased as we roll out Zen 2 in 7 nanometer as planned. And of course, have our Zen 3 design on track, because it's about the trajectory that we're on. We called our play, our roadmap is stable, and we are executing. And that's what our customers need from us. That's what we're providing at AMD. And it's a trajectory that clearly has AMD back in addressing the most demanding applications in the data center for today and in the future. Moreover, we are accomplishing our goal we set out to do, and that's to be a fully bankable supplier for x86 high performance in the industry. And you don't get there without taking some pretty big bets. And that's exactly what we did. You look at what it takes to get to that leadership position, what it takes to get to those world records. You have to make those decisions years in advance. It's the unfortunate fact about microprocessor and technology development is it's a multi-year lead time. And so we started right off the bat with 7 nanometer technology. We looked at it and we looked at the unique opportunity that full node could give us. We looked at it from a design standpoint. And we said, look, this is a second generation design, but it can't just be a bump off of Zen. We ended up touching most every execution unit in our Zen CPU and coming back at it, driving the most performance that we could. And then, of course, our Infinity Fabric. Because as you move forward in driving performance, you've got to keep that interconnectivity and that controllability to equally scale with the design elements. And of course, security is foundational. So with Zen 2 and our product family, we further strengthen our security posture. And that's what we'll spend a few minutes with, going through some detail associated with our big bets and the results. What do they deliver to our end customers? So we started with that 7 nanometer. It was a tough lift. 7 nanometer is a very challenging node. We were in 14 nanometer, 50 some odd masking levels and creating a 14 nanometer chip that jumped by over 50% in terms of the levels, and the resistivity changed and the patterning, and it created a challenge that couldn't be done without an incredible cooperation from design, the foundry, and the CAD and EDA industry. And that's exactly what we did. We took on that challenge. We also made sure that it would be highly manufacturable by the time that we needed to address the enterprise and server market. And so we leveraged mobile designs going out in front of us in 7, our Radeon product line, and our Ryzen high-performance desktop line, ramping up the volume and ironing out any manufacturing, smoothing and optimizations for yield in advance of this critical enterprise launch today. So, the next thing, the decision that we had to make some years back was how to take advantage, how to best take advantage of 7 nanometer. Because you could say, look, I'm going to leverage this technology to get, really half the power. It has tremendous energy efficiency. So you can take really half the power at the same performance. But that's not what server customers need. A server is power constrained. And so what you want is the most computing that you can deliver at the power that you provisioned for that rack. And so it was obvious to us. Take advantage of the density that 7 nanometer provided to double that cores in roughly the same power envelope which we had delivered in the previous EPYC generation. And so, that is really where 7 nanometer delivers. So it's right smack in the heart of what server customers need. More performance per rack in the data center. And of course, as I said, design. So if you look at the industry norm, IPC, instruction per clock, increases about 5% every year. So a normal trajectory would be about a 10% generational increase going from Zen 1 to Zen 2. But we achieved 15%. So it was really a great job by the design team. But I think it's really instructional to actually look under the covers a little bit about IPC. And when you do that, you can see, any metric, spec CPU, spec int, is a very, very common proxy. It's representative of such a broad range of workloads, and you see those elements, those components of spec CPU along the x-axis. And you see that there's a whole range, and that's how that 15% IPC is calculated. But what's further instructional is to not look at that single thread IPC uplift alone, but look at per thread IPC in the way that servers run. Servers take advantage of the cores that you provide them, most workloads. Single thread performance always matters. You have a lot of legacy workloads out there, but emerging workloads take full advantage of the cores that you provision per rack. And when you look at that per thread IPC uplift, looking across spec CPU as well as some additional server well-known benchmarks that we show, what you see that the mean increase is actually 23%. And in fact, certain workloads achieved an over 40% gain generationally. So first generation EPYC to second generation EPYC, looking at the same 32 core in a socket, ISO, same frequency, same memory configuration. That's impressive. And that really speaks, when you look at that proxy, is that there was a tremendous amount of design work that allowed that doubling of cores, yet to bring that same IPC, in fact, grow the IPC significantly from generation to generation. And, it's no secret. So how do you get that kind of an improvement? It's really hard, focused, microprocessor, microarchitectural engineering that delivers performance. You can't hand wave when it comes to server workloads. And so, it starts with the front end, right? From the front end standpoint, there's a brand new branch prediction approach. It's called TAGE. It's a state-of-the-art branch prediction, higher accuracy. We doubled the op cache in Zen 2 from the previous generation. We doubled the set associativity in the L1 iCache. And so when you put this all together, our prediction, our fetch, our decode capabilities with these enhancements as well as others brought a tremendous more efficiency to our front end. And then the integer units, where we widened, we actually increased our issue width. We went from 6 to 7 on our issue width. And we also added a third address generation unit, and we deepened our scheduling window. We added more registers. We increased the size of the reorder buffer. So again, this isn't magic in microprocessor engineering. This is how you bring more performance or more instruction per clock. And then the floating point. Well, we did very significant overhaul of the floating point. We brought it from AVX1 to a full AVX2 native implementation. We doubled the vector width from 128 bits to 256 bits. And in doubling the width of the vector, that only yields actual performance if you double how you feed it. And that's exactly what we did. We doubled the load store bandwidth into the floating point engines. And this is key. You look at fluid dynamics, so weather modeling, molecular dynamics, all of these type of HPC kind of workloads really rely on this type of efficient vector calculation. A great example is DGEM, double precision matrix math, very, very common. And when you look at that DGEM performance on EPYC, we doubled just on a per core basis with those changes made to the core, we doubled the performance per core. But we already doubled the number of cores per socket. And so as Lisa said earlier, that's 4x floating point performance per socket, and you just see it when you run DGEM. You see that actual quadruple of performance per socket. That's performance that matters to our customers. And then caches. Caches are fundamental in microarchitectural engineering, and we took a big step. We doubled the size of our level 3 cache from 8 to 16 megabytes, and of course that's across the whole core complex. What it ends up doing is really bringing that data closer to the execution engines, because when you can have more data stored locally, you're hiding that latency, because you can have a higher hit rate in your cache subsystem and not have to take that longer latency to get out to main memory. So all of these add up, and that's how we deliver the performance gains going from Zen 1 to Zen 2. Very great job by our microprocessor engineering team. And then, I've often talked about our hidden gem, the Infinity Fabric. Well, yet again, in generation 2, as we moved forward and we drove the kind of performance improvements I just described, you can't rely on that technology, that fabric technology that we had the previous generation. We have to scale. That's how you bring real-world performances. You have to amp up the provisioning in the next generation. And so that's what we did. We use this, this is broadly used, as you know. Our Infinity architecture is applied across our whole CPU and GPU portfolio at AMD. And what we did in the case of our second generation EPYC is we increased the bandwidth, lowered the latency across the chiplet approach that we described. So chiplet to chiplet is those CPU chiplets attach into this I/O die. I'll describe in more detail in just a moment. We increased the efficiency chiplet to chiplet, and that same Infinity architecture extends from the socket 1 to socket number 2, where we, again, implemented increased I/O bandwidth and make sure that we do not introduce any bottlenecks in that connectivity. But that broader architecture allowed us to implement hybrid technology. 7 nanometer CPU die, optimized for the technology, versus 14 nanometer for the I/O and memory control die, which does not scale. Those analog mixed signal type circuits and some of those elements simply don't scale as well, going from technology node to technology node. So that's what we did. We leveraged that, and the best way to see that is looking at a socket photo. So you see a single EPYC on the left and a single EPYC socket second generation on the right, and it's very visible to you, that difference. We maintain with Infinity architecture the same SoC, the same system on a chip approach that we had done in generation 1. But generation 1 was organized in a multi-chip carrier, so we had 4 SoCs connected by that Infinity architecture. But in the second generation, as well as amping up the performance, we put in the flexibility, again, to go hybrid technology. So easy to make these easier to make 7 nanometer die. They're 70-some millimeters squared in area. And what we have is 8 cores in each, 8 die, all connecting in through the second generation Infinity Fabric to that 14 nanometer I/O die, and then on to I/O memory. So the benefit is that flexibility, the configuration options that we have, that we now enable our customers to develop many more options of configurability, and also importantly for our customers is a more unified memory architecture with this design. Again, 8 CPU dies coming into a centralized I/O memory die, and then out to the associated memory and I/O channels, and still keeping the high provisioning that we had, 8 memory channels and 128 PCIe lanes. So, very, very key improvements that we made going from first generation to second generation. But we didn't just keep those memory channels in those I/O lanes the same. We amped up both of them. If you look at what we did, we doubled the I/O bandwidth, we doubled the memory density, and we increased the memory bandwidth. In fact, the speeds of the memories went up to 3,200 megahertz. And when you take that across all 8 channels that we feed, what you end up with is an industry-leading 204 gigabyte of memory bandwidth. Industry-leading memory bandwidth. And what we did from a standpoint of configurability is we actually decoupled that memory frequency from I/O, so we have many more options that we have of how many memory channels are deployed, and again, the ultimate SKUs that customers can offer, leveraging second generation EPYC. And PCI Gen 4, it provides leadership. As I said, it's a doubling. And so for the x86 market, being able to go from 8 gigatransfers per second on those lanes to 16 gigatransfers per second with PCIe Gen 4, it matters. It matters in application performance. And I've got a couple of examples that are pretty straightforward. You look at where that PCIe Gen 4 makes a ready difference. 2x the read-write bandwidth, and it scales linearly as you add non-volatile memory. So you have an application that's very dependent on IOPS. You saw already in first generation EPYC how with 128 PCIe lanes, you surround that with NVMe, you have just a phenomenal IOPS that you can provide for server applications that leverage NVMe, and now double that type of read-write bandwidth and scaling as you add NVMe drives. Fantastic. And another example, network performance. You look at a doubling of the InfiniBand read bandwidth going from PCIe Gen 3 to Gen 4 on this InfiniBand NIC. So again, this is, and I haven't even gone yet to, of course, accelerators, right? You take PCIe Gen 4 to GPUs or Radeon GPUs, into other industry accelerators, and you're going to reap that same benefit. So put it all together. Infinity architecture provides scalability. And I show an example first with on the left side with spec int rate, and on the right side with spec JBB. And you see near perfect scalability. And that's really hard to do in a fully coherent, symmetric multiprocessor. And it takes the type of changes I described. We doubled the L3 cache, as I said. We improved the memory bandwidth, the prefetching. We have a very sophisticated coherency mechanism that we added with second generation Zen. And we improved the socket to memory latency. All of those things added up and were necessary. And when you look at that, across one socket, can we in fact do that across 2 sockets? And the answer is yes, because we improved the fabric frequencies, socket to socket. We improved the memory frequencies, we improved the cross-socket bandwidth, and we added efficiency improvements. And that enabled us not only to scale within socket, but socket to socket across our 2P configurations. So near perfect scalability with second generation EPYC. All right. Well, I'll tell you, it's very fun. I could pretty much go on forever sharing on behalf of our engineers at AMD what we've done from an engineering standpoint on the design. But I think it's a lot better to hear from customers. And I'd like to start with hearing from a really great partner of AMD, whose company Dell EMC is doing extremely well in the market. And I am extremely pleased to introduce Robert Hormuz, who is Vice President, Fellow, and CTO of the Server and Infrastructure and Systems for Dell EMC. Robert, could you please join me?
Mark, how are you doing? Great.
Very good. Well, Robert, it's great to have you with us.
Yeah, it's an honor, Mark, to be here at this historic event and a great accomplishment to the AMD team, so congratulations.
Well, thank you for the commitment, the great partnership, the work that we've been able to do with you and Dell EMC. And Robert, I think it'd be great if we started and just heard from you some of the challenges that your customers are facing today in the server and data center space.
Yeah, that's a great question, Mark. I mean, we see, we have a deep engagement with a lot of our customers, and the pace of technology is moving very rapidly today. And there's a lot of new emerging workloads like machine learning, AI, data analytics. Digital transformation is everywhere, and so customers are having to embark on that journey. And it's kind of an interesting time because when you look at compute in general, we're kind of moving from this era where we use compute to create data to this era where we're using compute to consume it. And it's driving, a lot of new outcomes. And so businesses are going on this transformation, this digital transformation, to drive new outcomes in this hyper-competitive environment.
Well, here's the question. As they're going through those transformation, what's the challenge on, technology innovations that they need to help them speed that journey?
To go further on these, it's really about matching these new emerging workloads with the right platforms, with the right infrastructure, with the right technology. AI and ML needs high-performance CPUs and I/O bandwidth. Advanced analytics need incredible amounts of I/O bandwidth and speeds. Virtualization and VDI can benefit greatly from enhanced core count to drive up VM and VDI density. And so those are all keys that are all innovation areas that I think we need to improve on to enhance the architectures for our customers. And one of the things that I think what to expect in the future is you're going to see more and more adoption of these rich, powerful one-socket systems in the future.
Well, I'd like to hear more about that. And of course, I have a little bias here, so I'd love to hear from you how you've been able to leverage AMD EPYC as a way to attack bringing some of those innovations to market.
Yeah, so with AMD EPYC, it's enabled us to really focus on some real fundamentals, around enhancing our platforms, optimizing for unique things, and to take advantage of all those new capabilities that you bring. So, we look at it from what AMD is bringing today in terms of, architecture improvements, performance and security, and apply them to the Dell EMC PowerEdge portfolio. And so, with what you've done with multi-chip architectures, with 64 cores, to getting to twice the I/O bandwidth, to getting up to 128 or 160 lanes of I/O, we can really enhance a lot of our unique platforms in our portfolio.
Mm-hmm. And just if you just tell us a little bit more about that in terms of the PowerEdge itself. I mean, is there, what have you found has really been able to help you in your portfolio?
Yeah, so we've been, we have a great first generation EPYC portfolio that we launched with you a while back. And so we continue to engage with our customers deeply and, make sure that we enhance and take advantage of all the unique capabilities that you bring. And so, for example, two of the first generation platforms that we brought to market were rich one-socket configurations that were really disruptive and first in their class and a new disruptive TCO for the market.
Well, that's great. I've read your blogs. You've been prolific in sharing with us in the industry on some of your thoughts there and how you've deployed that in PowerEdge. Of course, then I have to ask you, we're excited to have you with today. What can you share with us on what's coming from Dell EMC in the future?
So what we're going to continue to do is optimize and listen to our customers. Look at these new emerging workloads. Look at how we can take advantage of your unique architectures, how we can optimize our platforms to take advantage of that. So we'll be expanding our AMD server portfolio in this fall. And we'll be continuing to enhance that around the workload optimized that are best fit for our customers.
Well, that's fantastic. I cannot wait to see the new PowerEdge servers coming out this fall. Robert, thank you so much.
Hey, thank you, Mark. Enjoyed it.
I'll tell you, the modern data center, you look at the kind of challenges that Robert just described that really, frankly, all of us in the industry are looking to take on. It's going to be a very, very exciting time. But one thing's for certain, and that is where we all, of course, have to stay focused on is security. And so I wanted to spend a minute and talk about our security focus at AMD. It's job one, it's foundational with what we do. And you look at our designs, they've been very resilient. We had put out robust software mitigations when the Spectre version 2 exploit had come out. But what you'll find is that since then there's been a number of other exploits, and in fact, most of them had not been applicable to our microarchitecture in Zen. So what have we done? Actually, I want to comment, there was a swap.gs exploit even that was came out yesterday, and there's 3 components of it. 2, again, are not applicable to the microarchitecture, and the 3rd component is already handled by a patch that came out from Microsoft. So we stay focused, and I'll tell you what we've done in Zen 2 is again hardened further. So we looked at the learning from Spectre. We hardened where we did for Spectre V2 and V4, where we had applied workarounds with our software partners or with our microcode. We hardened those in the Zen 2 implementation. So we've taken a strong security, we've made it stronger, and we continue to stay incredibly focused on security going forward. In fact, in addition to hardening those features, you heard mention from our key customer earlier about the EPYC secure processor. So we have a processor within a processor on our AMD chips that do establish that root of trust. It's an isolated processor, security processor, so that continues. We have the SME, where you can take our memory and on the fly encrypt as you go through the memory controller with negligible performance. So SME is a key feature of our 2nd gen EPYC. And then SEV, our ability to encrypt partitions and really take advantage in virtualized computing. So virtualization is so dominant in our field today, and we have support for 15 unique cryptographic keys in our previous generation. That is now 509 unique cryptographic keys that can be supported with SEV2 in 2nd generation EPYC. So we're very excited about this, and I think it's going to really expand our offerings and our product adoption, these key security features that we offer on the EPYC platform. And what I'd like to do is not just security, but the overall challenges, looking at virtualization and what it's taking on to further performance efficiency for end customers in enterprise and the data center. I'm super pleased to invite to the stage from VMware, Krish Prasad. Krish is a Senior Vice President and GM of the Cloud Business Unit. Please welcome Krish.
Thank you very much.
Thank you, Krish.
Congratulations. Good afternoon, everybody.
Well, really appreciate you joining us today. And probably to get started, it'd be great to hear on some of the challenges that VMware is focused on to really help our IT industry.
Yeah, it's exactly what Lisa was talking about in the beginning. If you look at our customers, they are in the midst of their digital transformation journey. And as part of that journey, enormous number of apps are getting developed. And analysts say that in the next 5 years, you will have more apps developed than in the last 40 years. That's the pace of innovation that we are seeing out there. And Mark, as you well know, these apps are different than the traditional apps. They are data-driven, a lot of analytics built in, and in many cases, it is machine learning driven. And one other difference that you see today is that these apps are deployed across a distributed compute fabric, whether it's in the customer's own data centers or in the public clouds, sometimes in the telco clouds and even to the edge. And VMware's focus has been to provide our customers with a cloud foundation that they can use to run any application on any cloud and access those applications on any device. And you well know that we have a partnership with AWS, which is the VMware Cloud on AWS. And recently we announced partnerships with Microsoft as well as Google Cloud, where our solutions are being run. And so the VMware Foundation running on all these clouds give our customers consistent infrastructure, which will simplify their operations and provide them with good performance and security.
Well, Krish, I've been very impressed with that versatility of the VMware platform, and it's very clear with the adoption level, the momentum that you all have established. And talking about momentum, I feel very proud of what our teams have been able to establish. We've had a deep working relationship over the last 5 years, and I'd love to hear your thoughts on what's come out of some of this collaboration.
Yeah, I mean, we have had a long history of collaboration between the two companies, much before I joined VMware. Our focus has always been, let's maximize the performance and scalability of the enterprise workloads. And that's the same focus that we put on as we embarked on supporting the second generation EPYC processor on vSphere. And I have to say, you heard a tremendous number of performance numbers and world records today, and many of them running on vSphere. And so all the work that our teams collaborated on is paying huge dividends, and we are actually setting a new bar for performance in the industry, working together.
Well, that's great, and performance is key. Optimizing performance is fundamental for end customers, but as I mentioned a moment ago, obviously security is very important, and we've increased the flexibility and the number of options around from an AMD platform with secure encrypted virtualization. Would love to hear your thoughts on the history. How did we get here? How did we able to actually collaborate with you and your team in regard to this capability?
Yeah, I mean, let's start with the customer. As they deploy applications across this distributed fabric, security becomes even more paramount. And the key is, if you can build in intrinsic security at the hardware level, it's much easier to enable the security where the application is actually running. And so that's what the SEV feature allows us to do. It actually takes out human errors, process related vulnerabilities. If you can enable it in the hardware, it is right there where the application is running. So I have good news. We, as a result of our partnership, we are going to be supporting SEV as part of the upcoming VMware release in the future. And in fact, this is something that we started working on many months ago, actually, maybe a couple of years. When you first approached us with the idea, we loved it, but we had certain enhancements and features that we wanted to put in it. And I was very impressed with the way AMD responded to it. You took security very seriously, and we worked together, both the teams from the companies, and I think we have a fantastic solution that we have come up with. And you can actually see it running. It's working. It's in the booths up there, so please, after the event, please walk by and see the demo in action.
Wow. I could not be more excited about this announcement. And honestly, Krish, I'm also really proud of the way that the teams work together. That's a hallmark at AMD. We pride ourselves on the ability to listen. Here where it was a very good feature, you liked it, but it wasn't quite there, and that's what we're here to do: is listen, respond, and thank you so much for the partnership and bringing this key capability to market.
Thank you very much. Congratulations.
Thank you. All right. Well, I'll tell you, I want to wrap by talking about momentum, the high performance momentum, because this is what it's about. Again, we're a technology company. We're here to bring performance to the market, to help customers solve the toughest and the most demanding problems that are out there. And you look at Zen 2, it's what we do best at AMD. It's innovation to deliver more performance and value, and to really help our customers in terms of solving what they need, right? And delivering that value to the end customer. We saw the opportunity of 7 nanometer. We took advantage of it, right? We brought more performance, more cores in that same rough power envelope, leveraging that technology. We drove more instruction per clock. We drove up the design capability. We took advantage of the modularity and the scalability and the enhanced security of Infinity architecture. And what it's led to is another huge step in supplying the industry with that insatiable demand for more processing capabilities at every generation. And so it is, in fact, insatiable. We can't let up. We won't let up. And I couldn't be more pleased to share that as I committed, we always are working on the next designs while we're doing a current design. We're well along. In fact, we've completed the design phase of Zen 3. So Zen 3 is right on track. And we don't stop there, right? We already have our engineers in the works on Zen 4. So it's really fundamental for us to keep momentum in the industry. You know, I have to say that we have focused on showing the industry that we have a roadmap that we can deliver to enterprise and data center as promised. As promised. We know that it's a highly competitive environment that we are in. But for us, it's personal. It's personal. We will not let up. You have our commitment. Thank you very much. And with that, I am very excited that we hear about how this technology translates into our system implementations from my colleague and my EPYC partner, Forrest Norrod. Please welcome Forrest.
Thank you, Mark. Thank you, Mark. It is personal, and it's a journey that the whole AMD team has been on for the last few years. You know, 2 years ago, as Lisa said, we launched the first generation of EPYC, and it was just that, EPYC. For a server guy like me, it was a highlight of my career, only surmounted by today. Because today, we are delivering the world's highest performance x86 server CPU ever to the market. We've already talked a lot about the speeds and feeds, 97% more performance than the mainstream top-of-stack Cascade Lake, more memory bandwidth, more cores. You've heard the story already. 32 billion transistors in the EPYC second generation processor are delivering an incredible amount of performance and enabling an incredible disruptive TCO to come to market, offering scalability that the industry desperately needs. And that can be delivered in a couple of different ways. When we first launched EPYC, we began really promoting the concept of an optimized, no compromise, one-socket server system, where the artificial constraints placed upon the system, perhaps in the desire to always sell 2 CPUs, were broken, and where customers could choose the right system, the right performance for their problem. We're continuing that journey today with an even more exceptional single-socket offering that offers ultimate in TCO. But we're also delivering the ultimate in performance with the 2-socket EPYC system. And so I'd like to talk a little bit more about that one. That 2-socket delivering the ultimate in performance comes about because of all the architectural features that Mark reflected on for the last few minutes. Highest core density, offering the most throughput. Leadership memory bandwidth. Standing in front of that memory in a 2-socket system, over half a gigabyte of cache, for crying out loud, which is truly opening up and unlocking the performance of that core complex. And of course, doubling the system throughput means that you can feed the beast, that you can get your data in and out from the networking and storage devices, delivering truly unmatched performance. And let's look in more detail about what that looks like across the stack. If you take a look and you compare the mainstream Cascade Lake processors from our competitor, great set of processors, EPYC matches up very, very well. So against the bronze, the 8-core bottom of the stack EPYC processors offer tremendously higher performance than the bronze scalable Xeon SKUs. But if you need more performance, you can jump up with the 32-core EPYC parts and cover the entire performance range of the Cascade Lake Scalable Xeon systems, up to the top of the Platinum 8280 range. And that's fantastic, but that's not where it stops. Because with EPYC, as Lisa already told you, you can go beyond that. You can go to 48 cores and offer yet more performance, or you can go all the way to the ultimate. The 64-core EPYC 7742 offers double the performance of the top-of-stack Intel Cascade Lake. AMD's engineering team has done a great job with delivering this level of performance, this level of disruptive innovation. I'm incredibly proud of what they've done. But what that translates into is that 80 world records as of today and counting. Every day adding another world record, and not just in one narrow range, not just in one application, not just in one segment, but world records across a full range of workloads that you see in the modern data center, from high-performance computing to enterprise, software-defined infrastructure, big data, cloud, you name it. EPYC is delivering truly exceptional performance, which is, again, just an incredible point of pride for AMD and for all of our system and software partners. And in looking at that performance a little bit more deeply, I want to hone in to the enterprise side a little bit, because the Java performance, which is so relevant for so many on-premise enterprise applications today, is truly exceptional. Offering 68% more crit ops performance, 83% more throughput performance. That's real performance that we're bringing to the enterprise. And you might say, well, so what? You've got some pay for us. You got great 80 world records. You got great benchmarks. It's just numbers on a slide. Who cares? Who cares? Well, our customers should care. Because in the real world, that level of performance translates into disruptive economics. If you take a look at a typical on-prem deployment of an online retail store, in this particular example, the customer had 60 Intel 2-socket servers, delivering in aggregate very high performance, 11 million Java operations per second, powering that retail store. Well, that same level of performance with EPYC can be delivered in a completely different way. We can deliver with 2-socket second-generation EPYC that same level of performance with 83% more performance per server, translating into 45% fewer servers, 33 versus 60, which means 44% lower total cost of ownership all in. The companies that deploy EPYC will have a strategic advantage because the performance that we give them translates into materially lower total cost of ownership, allowing them to spend more money on innovation, more money on customer support, more money on driving their business, rather than just providing the infrastructure. That is truly disruptive. That's the power of AMD EPYC. And of course, beyond the enterprise, there's nowhere where high performance is more important than, of course, in high performance computing. Sort of the name defines the importance of performance. And in high performance computing, those benchmark results, those world records, translate into real world performance for the scientists and the engineers, the product designers and the researchers that need to use high performance clusters of systems to design new products and to do scientific research. And across the board, you will see upstairs in the transformation zone, you will see from our partners over the next days, weeks, and months, example after example in the real world, running real codes, running real applications, that second-gen EPYC delivers incredible performance to speed up research, to enable better product design, to truly be disruptive. And that's why you see so much interest in the second-generation EPYC in Rome, and why we've already notched multiple HPC design wins even before we began production. And so, to tell you a little bit more about the reaction and the excitement in the HPC community, there's no person better than the leader, longtime leader in HPC, which is Cray. And so I'd like to invite Pete Ungaro, the CEO of Cray, to the stage. Pete, thanks very much for coming. We really appreciate you being here. And more importantly, we really appreciate the partnership that we've had between AMD and Cray for many years, and most notably in the last few years.
Yeah, absolutely. Thanks, Forrest.
It's been fantastic. Now, Pete, I know that Cray sees the landscape in traditional HPC market really changing and the applicability really going beyond. Can you tell us a little bit more about that?
Yeah, absolutely. You know, at Cray, what we see coming is a whole new era of computing. An era being driven by macro trends like digital transformation and the explosion of data that's swamping almost everybody's data center today. And a cloud-enabled open source software ecosystem that's really accelerating the pace of change. And so as we talk with our customers, as I know you guys do too, it's really about the questions that they're trying to ask are changing, and the workloads are changing, and the whole industry is changing, and it's time for the data center infrastructure to start to change.
Could not agree. Time for change. Could not agree with you more. That's a big reason that we created EPYC.
Yeah.
So, you know, how are you approaching this opportunity? How are you realizing that change?
Well, you know, about 5 years ago, we started a process and really a journey at Cray to really start to rethink the data center and to really rethink about how we're going to build and architect a machine for the future. And that really has come together in what we call Shasta, which is an architecture that's built for the next 10 years of processor and accelerator architectures going forward. So we're pretty excited about pulling all of that together. From the ground up, Shasta's been built as a data-centric architecture, really thinking about these workloads, thinking about the convergence of the applications from IoT to artificial intelligence and analytics and modeling and simulation, and bringing those all together on a single system, bringing those all together in a single workflow, and doing it at unprecedented scale and often in real time, as people need to do today.
Yeah, and you guys have got quite a few innovations in there. I know you've got a new fabric as well powering this.
Yeah, absolutely. You know, I think one of the big things that we've seen is really a need to pull all of this together, both from a software perspective and a fabric perspective, and bringing that together in the system. On the software side, we've really worked toward a cloud-enabled software environment, so providing the flexibility of the cloud and the performance that you'd expect in a Cray supercomputer, and bringing that all together in one system. And as you mentioned, that just goes right now down to the fabric, and the fabric that connects it all together, which is Slingshot. Slingshot's a really amazing rethinking of that fabric and how we build this fabric, not just for high performance computing, but for these new workloads like analytics and AI, and what the capabilities that we need there. For instance, things like congestion management, as well as really looking at the network and making sure that all of the applications can complete at scale, unprecedented scale, on time, as fast as humanly possible. And you're right, we call that Slingshot.
It's fantastic, fantastic design. So I think, you know, you're already seeing some pretty good traction. You got some pretty significant wins with Shasta already.
Yeah, absolutely, Forrest. We've had incredible momentum. You know, about a year ago, we introduced EPYC to the Cray lineup, and since then, we're starting to approach about $1 billion in new bookings on the EPYC line, which is super exciting. The machine that you have up here is the kind of granddaddy of it all, Frontier, which is a system that we got to stand together with you and Lisa and Mark, together with the Secretary of Energy in Oak Ridge National Laboratory, and talk about the next generation of computing, an exascale computer. This system is going to operate at more than 1.5 quintillion operations per second. And just to give you a perspective, if you take the 100 fastest supercomputers in the world today and combine those all together, Frontier will be faster than all of those based on Cray and EPYC.
That's incredible. That is truly an amazing leap. So you've got some other wins. It's not just as big and as exciting as Frontier is. You've got some other great wins as well.
Yeah, absolutely. You know, just across the bay from us, we have NERSC, the National Energy Research Scientific Computing Center, who's getting a brand new Cray Shasta system with AMD EPYC processors to support their 7,000 scientists that they have to support across a broad range of applications and workflows and solving some of the most complex scientific challenges on the planet. We also just announced at the Department of Defense their high-performance computing modernization program. We're going to install 2 EPYC-based supercomputers with the Department of Defense, but it's not just all about the research laboratories. We're also doing the same thing in going after commercial applications that are very challenging. You know, Rich Energy Haas1 F1 racing team, the guys that are trying to build the fastest and most fuel-efficient cars on the planet, are using a Cray supercomputer with EPYC processors as we go together, and really, they've seen 45% performance improvement on the previous generation of EPYC overall.
That's fantastic. Yeah, that was with first generation. They'll see even more with second. But I know you've got one more win to talk about today.
Yeah, we're super excited to be here today and announce a brand new win for us that we're just announcing today with the Air Force Weather Agency. They selected a Cray supercomputer with Rome processors to do weather forecasts, really high fidelity weather forecasts for the U.S. military operations around the world. This is really exciting for us because this is the first Shasta that's going to be delivered into the weather segment. It's a brand new customer for us overall. And Forrest, as you know, weather is one of the most challenging workflows on the planet, and the high memory bandwidth of EPYC is really important for that.
No, it's fantastic. Some great wins together. And then I think we've got one more win to talk about here today.
We got one more. So one of the things that, as we really think about delivering our systems to more and more customers across every data center, I'm just incredibly honored to introduce Matt Link, who's the Vice President of Research Technologies at Indiana University, who will be the first university customer to get a Shasta machine with EPYC. And let's welcome Matt onto the stage.
Hey, Matt, thanks for coming. Really appreciate you being here today.
Thanks for having me, and thanks for you guys taking a little slice of your life to spend with me in Indiana University today.
Appreciate it. Hey, so tell us more about why did Indiana University choose Cray and AMD?
So our relationship with Cray and AMD, we've got a long relationship, has been one of the best experiences we've had in the HPC industry. And we take that experience and we couple that with the superior core count, high memory and I/O bandwidth of the EPYC processors, and we're going to enable our researchers to scale their research within a single node and allow them to do more, do it faster, to really drive towards what my mission is at IU, is to reduce our researchers' time to science.
Time to science, I like that. So tell us more about it. The name of the system is Big Red 200?
Big Red 200. It's named after our bicentennial, which is this fiscal year. It's a Shasta supercomputer with EPYC processors.
Great choice, man.
And there's about 6.7 million people in the state of Indiana. If every person did a calculation every second, my number's not going to be as big as Pete's quintillion number, but every person, every second, it would take them 28 years to do what Big Red 200 will do in 1 second.
That's awesome, man. Tell us a little bit about the research that you guys are going to do on the machine.
So our research is focused on the grand challenges. It's not just the grand challenges in the state of Indiana, but those facing humanity. Modeling, simulation, AI are critical to IU's grand challenges of precision health, prepared for environmental change, and responding to the addictions crisis. We're also very focused on the exploration and advancement of AI in education, cybersecurity, medicine, and environmental science and more.
You know, and Matt, you were telling me that first Big Red and now Big Red 200 also, really helps bring grants to the university.
It does, and over the past 6 years, Big Red 2, which was the predecessor to Big Red 200, and our HPC environment, our researchers have brought in almost $750 million in grant dollars to the university. And that really enables us to support and empower them to continue those important initiatives.
That's fantastic. That's fantastic. Well, Matt, really, really impressive. Thank you for sharing this with us.
Yeah, thank you for having me. I appreciate it.
Thank you so much.
Thanks, Pete.
Pete, thanks a lot. Really appreciate it. Take it. So, HPC is kind of sexy. I'm an engineer. HPC is sexy. Enterprise, we don't normally think about as being sexy, but it is critical. It is foundational. It's foundational to business and foundational to all of our lives. And the performance that EPYC provides and the TCO advantages that EPYC provides are, incredibly important to help enterprises with their IT challenges. So on the performance side, we've already talked a little bit about this, but EPYC offers demonstrably superior performance across a broad range of enterprise applications, from the Java results that we've already talked about to the #1 world record on Hadoop for data analytics, 43% better SAP performance, and the world record for virtualization performance using SpecVirt, truly enabling high performance. And that performance delivers a completely changed economics of the virtualized data center. We talked about this before with respect to the Java performance, but I want to show you what the single socket server can do to the virtualized data center. So the single socket server with EPYC 2nd generation is not your father's single socket server. With constrained core count, with constrained performance, with constrained memory and I/O capability. This is unconstrained, unrestrained, delivering tremendous power efficiency and density advantages because it's in a single socket configuration, offering substantial CapEx advantages as well. But with those reductions, giving up not an iota in features, with all of the resiliency, availability, and reliability features that enterprises demand, and of course, all of the security that they so desperately need here today. And then for many applications, ones that are licensed on a per socket basis, 2nd generation EPYC also provides an incredible opportunity for reducing software licensing costs, and again, unlocking the capability to deploy yet more performance. And so, if you take a look now at our single socket stack versus the Intel single socket stack, Intel did, with this latest generation, introduce an optimized set of single socket configurations in Cascade Lake. And I'm pleased to say that with the EPYC single socket configuration, our 32 core variant can cover, again, the entire range of the Intel single socket configurations. And going up to 48 or 64 cores, we can again more than double the performance of the highest end Cascade Lake Scalable Platinum SKU from our competitor. Maybe more importantly, because I often got, over the last couple of years, I've often received, the question, what is a single socket server good for? It's a new thing. What's it good for? I've been buying dual socket servers for years. That's what I do. I buy dual socket servers. Why are you messing with my data center? What am I going to do with this single socket server? Well, you've got to look at the performance again of the single socket server compared to the performance of the alternative dual socket server. And I say to you, you can do anything you can do on a dual socket server with the AMD EPYC second generation single socket server because it outperforms the entire Intel Cascade Lake stack up to the 8280M in a single socket configuration. And so what does that mean? Well, it means for the companies that are deploying on-prem virtualization farms, and a typical configuration might be about 2,500 cores, typically deployed historically in a dual socket configuration with, of course, VMware, you can do that same level of, same number of cores, same number of virtual machines, same performance or better with 50% fewer servers, with 1/4 of the sockets, driving 61% reduction in power, and driving 75% lower software licensing costs for your VMware license. What does that mean? That means a 54% reduction in the total cost of ownership for a fairly standard on-prem enterprise data center farm, on-prem enterprise virtualization farm. That, again, is truly disruptive economics. That's changing the economics of the virtual data center. And I'd like to say that, one of our partners in really driving an optimized set of enterprise class, no excuses, no compromise, high performance, single socket server systems is an old partner of AMD's, a great partner of AMD's, Lenovo. And I'd like to invite Doug Fisher, the COO of Lenovo's data center group, to the stage. Hey, Doug, great to see you. Thanks for coming.
Congratulations.
Appreciate it. We're super excited to have you here today. We're super excited to have you here with us on this journey. Can you tell us a little bit about what problems you're seeing from your customers? Lenovo is very customer centric. What problems are you guys trying to resolve?
Yeah, we're very, very focused on our customers. We spend hours and hours with our customers daily to understand their pain points and where they're seeing areas that we could bring more and more value. It's no secret, everybody talks about the catalyst behind a lot of the transition, the intelligent transformation that we're driving at Lenovo is data. One of the interesting data points I heard recently was if you take a look at all the data that exists on the planet today, 90% of that data was generated in the last 2 years. That's an exponential growth that we're going to see continue. And so because of that, a lot of the performance capabilities are needed to reduce the bottlenecks and drive more value for the customer, reducing pain points. These are things like high-speed storage in order to get that data into the processing capabilities, whether it's the CPU or accelerators. It's high-speed memory to accelerate latency challenges. All those elements are critical. Now, that data is super important, so they're very, very concerned about security. And every IT manager out there has a budget, and so operational expenses are very, very important. So we're working together to understand those pain points and resolve those.
Oh, fantastic. Well, our collaboration has been great. Tell us a little bit about the servers that you guys have built some pretty darn good servers with second gen EPYC. Why don't you tell us a little bit about them?
Yes, Lenovo has a broad range of platforms under the Think system. We're very proud to talk about 2 new platforms in our Think system lineup. These are the SR635 and the XR655, both based on EPYC. Now, the thing that's unique and nice about this platform is it's designed ground up to take full advantage of EPYC's capabilities. with the PCI Gen 4, as well as getting as many and dense storage capabilities we can in there. 32 NVMe, 2.5-inch NVMe in there for petabytes of storage to get that data as quickly as you can to the computing elements. And so we built all this from ground up with the EPYC in mind for our customers and the pain points that they hit. Now, I talked about several elements that are critical for our customers. One of them is performance. Lenovo has the moniker for the most world records in performance today on x86 platforms. We're proud to add 16 new performance records to our already world record achievements in this space. We're all about performance. We have 16 new performance benchmarks to announce today. Our performance is across a broad set of workloads that Forrest talked about. There's a broad set of workloads in the modern data center as the transformation happens. And so you'll see our world records across a broad set of those workloads, whether it's CPU, virtualization, Java workloads, a broad set of workloads we are targeting to ensure that they get the most optimized platform. But there's also another big point, which is ownership, cost of ownership. And so we're very proud to have the #1 world record in spec power to ensure that you get the most cost-efficient platform in your data center to reduce the power consumption as you're driving that capability in your data center.
That's fantastic. #1 most efficient server ever.
That's right. And I got to tell you something. Once you deliver that server, that's not the end of the story. It's about reliability. Lenovo holds the #1 spot in reliability. Even today, after 6 years in a row, we own that again. If you look at ITIC's report, and I encourage you to do, we have 6 years of consecutive leadership and reliability, #1 x86 server out there, and we are far ahead of our competition. The next thing is customer satisfaction. Performance, reliability leads to customer satisfaction. The independent study by TBR shows us as the #1 provider of customer satisfaction today. Security, you added some capabilities, hardware encryption capabilities. We have ThinkShield as our brand for security. It's not just about securing the platform, it's end-to-end. It starts at the supply chain, working with our vendors to ensure that every element is secure. It's doing the BIOS and the firmware, ensuring that that code is secured, development is secured. And then the platform, where we're taking full advantage of the ThinkShield capabilities to include the virtualization, encryption to secure the virtual platform. So we're going end-to-end on security as well.
That's fantastic. And I know you've already been working with customers with these systems. Can you tell us a little bit about what your customers are doing with these?
Well, you look at those pain points, and we work with partners to help solve those pain points for the customers. Smart cities are becoming the norm. Having security surveillance capabilities to ensure that you secure your city, airport, municipality are very critical. We've been working with a partner, Pivot3, for years to ensure that they could deliver the most robust solution, solving the pain points they have and delivering their capability. Imagine 4K videos, thousands of cameras streaming in. They need the large storage. They need fast access to that data to compute on it. They need access to the 6 GPUs that we can put into the box to compute on that, to deliver that value. And so all those pain points I talked about end-to-end, Pivot3 is actually utilizing those capabilities today. They're in the showcase. I'm telling you, I've seen this demonstration when I was in Barcelona. It is phenomenal. I tell you, you would not believe what they can do with the video surveillance capabilities. I encourage you to go out and look at that.
Definitely check it out. It's something to see. But you've got another customer you wanted to talk about as well.
That's right. We've been working for a long time with our customer, ALI. They are a leader in network intelligence and security. They are utilizing all the capabilities to solve those pain points that we deliver a solution together to ensure that they deliver the best value for their customers. So let's hear it from them.
Alog is an innovative provider of network intelligence and security solutions that empower many of the world's top communication service providers and enterprise. We have worked with Lenovo for many years already, leveraging the breadth of Lenovo portfolio. We see great potential for enhancing the delivery of optimized solutions to our customers with the introduction of the new AMD-based Lenovo ThinkSystem line. AMD EPYC 7002 architecture will increase performance, will increase scalability, while reducing rack space and power requirements. The solution will enable a lot to provide TCO-optimized offerings to our customers and accelerate the value of insights derived from their network.
So really, as you can see, working with our Think System capabilities, number one performance, 5.9 reliabilities, customer satisfaction, security, and TCO, partnering with AMD, we're delivering that capability in these new platforms.
That's fantastic. And both of them, both of those cases, I think, really also highlight the importance of PCIe Gen 4 and what flows from that.
We utilize all those capabilities. We're packing in all the performance we can. This platform, both these platforms are shipping this month. They'll be delivered in the traditional way we do. We're a channel-first company. If you don't know what that is, look it up. We're all about partnering with our channel and ensuring that we have the best partner for our channel, as well as we have a model. It's not the traditional leasing model. It's called TrueScale. TrueScale actually is a much more innovative way to delivering that capability, where it actually looks at your usage, so you can provision a higher performance platform but only get charged when you use that peak value, maybe at the end of the month when you're closing books or whatever workload runs at peak times, you pay for it at that time and not when you're not using it. So it's a very innovative way of delivering our platform as well.
Very cool, very innovative. Well, I got to tell you, thank you so much. It's really been a pleasure working with you guys so far. Congratulations on a set of really fantastic servers, and can't wait to see what else we do together.
Right, congratulations to you.
All right, thanks a lot. Take care. So lastly, I want to talk about, before we talk about the stack, I want to talk about the last segment, which of course is cloud. And for cloud computing, it was one of our major targets for EPYC from the beginning. If you think about it, we built a throughput machine par excellence that could deliver far more throughput to power a large number of virtual machines, containers, and instances. It was all about offering performance and economics at scale. And so there's probably no one better to talk about that than one of our first partners on the cloud, which is Microsoft. And I'd like to invite Girish Bablani to the stage from Azure to talk a little bit about Great to see you again. Thanks so much. So excited at the work that we've done together for the last few years around EPYC. It's been a fantastic journey with you guys.
It's great to be here. It's been fantastic for us as well.
Excellent. So maybe you could tell the audience a little bit about what you guys have already done with the first generation of EPYC.
Yeah, so we've seen quite a bit of interest in Naples since we have released it. And as you know, we have two classes of virtual machines that we offer that are powered by Naples. The first is our LV2 instances that are basically dedicated towards storage workloads like databases, big data, etc., anything that needs lots of IOPS. And then the other one is our HB instances, which are high-performance computing instances. Both of these have seen a lot of interest from our customers. In particular, what we see with the HB series is really good performance and really good scalability numbers. So,
yeah, I've seen some of those numbers. They truly are epic.
They are. So what we see in terms of performance is that we can take advantage of the 33% improved memory bandwidth that Naples offers, and that lets us do a much better job with some of the high-performance workloads, in particular computational fluid dynamics. So when we run the Fluent system scaled across 6,000 Naples cores, we see a 54x improvement over what we have. And if you look at the system and you compare it against a corresponding leading bare metal system, you get 24% better performance than that. So this is kind of leading performance in the cloud, all powered through Naples.
Oh, that's fantastic. What's the customer experience been so far using that?
So the customer experience has been very, very good. We got great feedback, and one particular customer I'll talk about is Rescale. So Rescale is one of the managed high-performance platform providers that build on top of our HV-Series, which is of course powered by Naples. And Rescale is focused on aerospace workloads, so fluid dynamics, material science, etc. And one of their customers is Aerion Supersonic. And Aerion Supersonic uses the HP platform to actually design supersonic jet engines, which are going to be running on 100% biofuel.
That's pretty cool. I would hope that they would have their partners participate in some of the demo flights.
Did you see the jet park outside?
Hey, but so that's super exciting, real world examples. But tell me, you guys have been evaluating Rome for a while. Tell us, what's your experience or what's your thinking so far in Rome?
So we are very, very happy with Rome. So some of our preliminary numbers that we have seen on Rome, we see 100% improvement in our HPC workloads compared to Naples. So twice of what we already see with Naples, which means our customers can run even bigger and more performant workloads when they will be moving to this system.
That's truly remarkable. That's great scaling from second generation.
Right. Anyway, so we have three announcements.
Three announcements. Okay.
Three announcements of how we're going to be using Rome. So the very first one is we're going to be announcing our next generation of HPC, which is called HPV2. So it's going to feature 120 Rome CPUs, which are mated with a 200 gigabyte InfiniBand, which is the first time in the cloud. So, and this is thanks to the PCIe for support that Rome offers. So this is HPV2 that we're announcing. We're also announcing what we can call an AMD Square offering. This is our virtual desktop offering, which is going to be Rome paired up with a Radeon MI25, so you can run Windows virtual desktops on the system.
High performance VDI, A plus A, AMD plus AMD solution. That's fantastic. But you I think you said you had three announcements.
Yes, we do. So the third one is our general purpose. And so our general purpose series is the D and the E. So we are announcing DA and EA V3, which are going to be our general purpose systems based on Rome. And these systems actually are available for preview today as we speak.
Fantastic. And I think you're demonstrating all three of these upstairs.
Yes, we are. So they're going to be in the transformation zone, and we're also opening up the virtual desktop as well as the HPV2 for signups. So all of that's happening today.
Oh, that's fantastic. That's fantastic. So one of the fastest routes to Rome is with Azure.
It is indeed.
Thank you so much.
Thank you. Fantastic work.
Thank you. So definitely check it out upstairs. So look, across the board, from cloud through enterprise to HPC, EPYC truly offers workload performance leadership, delivering better results, faster results, better TCO, which is just fantastic. It's what we aim to do. And we're delivering that to the end users through a set of partnerships across the board, from systems to the operating system, from IHVs to the software developers who provide the apps that so many customers need. We've had exceptional partnerships, we've had exceptional support, and we thank particularly everybody from our partner community in the room. Thank you so much for helping us get day one support, not just support, optimized support for second generation EPYC ready to go. Thank you very much. And so now I'd like to talk about our role in that ecosystem, that open ecosystem that Lisa talked about, that partnership that we did. Our role is to provide a simple way for folks to consume this power, to see the advantages of second generation EPYC. And so we have a very simple, straightforward stack. Customers can choose the level of performance they want, the number of cores that they need for their application or workload, and procure that. No other compromises are entailed. Because with the EPYC stack, all features are included in every EPYC processor. The full set of reliability features, the full set of security features, the highest memory speed available in a modern server, 128 or more lanes of PCIe Gen 4, and leadership security features. Every customer gets it all. And the customers can range from the spectrum. So if you think about the customers who are looking perhaps for an entry-level server, they can choose, of course, an EPYC 7282 or a Cascade Lake Xeon Silver apart, with the EPYC 7282 offering far more performance for less money, giving that customer who wants an entry-level server over 2.5 times the performance per CPU dollar, offering a truly superior choice. If you look at the mainstream, what would often be served with a gold processor from our competitor, the same thing holds true. With EPYC, a mainstream 7452 part delivers substantially higher performance than the Xeon Gold at roughly the same price point, delivering 2x the performance per dollar for your mainstream workload. At the high end, for customers that demand the maximum performance, that have the most demanding workloads, that need the power of the top of stack, the EPYC 7742, as compared to the alternative, offers double the performance at a slightly lower price. Or as we like to say, high performance at a fair price. And so that translates into, I'm sure you've already done the math, 4 times the performance per dollar for people looking for high performance. That model of performance and price performance leadership, of offering our customers the performance that they need at a fair price, extends across the entire stack. If you look at the dual socket configurations of EPYC matched against the representative competitive choices, I think you can clearly see, first off, that the EPYC processors, second generation EPYC processors that roam, kicks ass! And so, I don't care what segment you're in, whether you're in HPC, enterprise, or cloud. I don't care what performance level you need, from the entry through the mainstream to the high performance. I don't care what features you need. The new standard for the data center, the new performance leader for the data center, the new price performance leader for the data center is the new benchmark for the data center, the new standard for the data center, and that is, of course, EPYC. And with that, thank you very much. I'd like to invite Lisa back to close.
All right, fantastic, Forrest, thank you. And now I hope you've just gotten a feeling of just the tremendous value and capability behind second gen EPYC. Look, we've told you everything that we have to tell you, all right? Proof point after proof point, and I hope it's absolutely clear to you now why second gen EPYC is the best in the industry. And we are not done yet, though. We're almost done. We're not done yet. We have one more special guest for you today. And look, our goal with EPYC are extremely ambitious. We really do believe that every single data center environment should use EPYC. And we want to ensure that we meet the needs of the most demanding environments in the world. There's no question today that's in the hyperscale environment. You've heard about some of the cloud environments, but there is also no question that one of the most demanding environments in the world today sits at Google's data centers. So with that, join me in welcoming Bart Sano, Vice President of Platform Engineering at Google, to the stage. Bart. Welcome, Bart. Thank you so much for joining us today.
Well, thank you very much, and congratulations to you and the team. And I've been hearing excited all day
Are we
today.
just a little bit excited?
Well, you're excited today, but I gotta tell you, I'm feeling even more than just excited. I'm feeling epic. So just today, I'm feeling epic, and I just would like to do that.
Oh, I love it. Look, Bart, you and your team are legendary. Okay, I mean legendary in the data center environment. Everybody knows you drive the hardest data center environment, the most innovation. You're known for the last drop of performance. So can you tell us a little bit about your demands in the data center?
Absolutely, that's very kind of you. Well, you know that Google operates data centers around the world. In these data centers, we're running some of the most demanding hyperscaler applications and web properties. These workloads need to run fast to meet our users' expectations. They also require scalability and throughput to address the billions of users we have across the globe. But most importantly, they have to deliver superior total cost of ownership to be affordable. So what we do is that we have to optimize across the entire stack, across many dimensions, starting from the data center design to the hardware systems that we work together, all the way through to the system software, through the application. And it's the reason why we chose EPYC.
Well, we really appreciate that. You know, Bart, AMD and Google have also had a long history together. So I can say that a few years ago, I went to see Bart at Google, and I sat down and said, hey, look, we have these ambitious plans around the Zen roadmap. I'm going to build this multi-generational roadmap. I want you to use our processors in the data center. And you were tough. You told me you needed the best of the best in performance. And I knew you would push us, and you pushed us. I'd love for you to share a little bit about the collaboration.
Oh, of course. I remember that meeting quite well, and I felt like it was sort of a tough conversation, but it was, you know, it was candid critique is really what it was. But I think what people need to understand is that that produces, through our collaboration, some of the most important technologies that help Google scale not only up in the capabilities per server, but out in the number of servers per cluster. So, you know, what's interesting is that those technologies that you provided, AMD provided us in that time, has culminated into Google's first 4-socket server, and really is our millionth server for over a decade ago. And really that shows, I think, the history that we have with AMD, our commitment to each other. And we chose AMD's platform at that time for many of the same reasons that we're here today.
Now look, we really appreciate that. And you know, when you really talk about the collaboration and how you pushed us and really worked with us to achieve performance on Rome, you know, we set out to meet and try to exceed your expectations. And frankly, we wanted you to be one of the first to deploy Rome in a production data center environment. So can you tell us where you are in your deployments and what you're seeing with Rome?
Certainly. And you know, that collaboration that we have, I think, is very important for us to innovate. I greatly appreciate that. And what we really, today, what we're very happy to announce is that Google has already deployed within our data centers, in a production data center environment, the EPYC second generation technology. So, you know, we're really seeing, the great thing is that we're already seeing some great performance on a variety of workloads. And I attribute that to several architectural features that actually Marc had alluded to before. Some of those are the high core count, and therefore thread count, the shared high performance memory architecture, and also your Gen 4 PCIe complex, which helps us scale and also integrate our own accelerators in an efficient manner.
No, look, I am very happy to confirm that Google was the first to deploy Rome in a production data center environment. So does that sound exciting, guys? And look, Bart, we've made a tremendous amount of progress. I mean, my engineers are in your labs all the time, and we really try to push the envelope. You guys push us. You guys tell us we're never, ever done. Can you tell us a little bit about what's next for AMD and Google?
Of course. So what's coming up next is that as we widen the deployment of this technology within our data centers, the end user can look forward to increased performance and functionality to the Google services they use and they love. For instance, faster or higher quality search results. And together, I'm confident that Google and AMD are going to continue to push and to continue to make the entire ecosystem more useful for everybody. And I think that's going to be to the benefit of the entire industry, quite frankly. Now, what we've talked about thus far has been principally Google's internal use for our own web properties. But what I'm here to talk about is we really haven't covered really the cloud applications or the cloud users that we have for EPYC. And so today, I'm excited to announce that we're planning to make AMD's second generation EPYC processor available to our cloud users via Google Cloud Compute Engine. And this builds upon our investments into the AMD platform and bring AMD-based VMs to market on our Compute Engine. So cloud users will benefit from a wide variety of VM sizes, from either 2 to over 200. The largest, actually, general-purpose VMs ever deployed or offered on GCE. So these VMs will deliver improved performance, we believe, for most general-purpose workloads, and 60% better memory bandwidth for big compute workloads like financial simulations, scientific computing, and even weather modeling. So we are very excited, EPYC, to offer AMD CPU and the associated benefits to our cloud users for really the first time. So,
what do you guys think? Google Cloud on AMD EPYC. Bart, thank you so much for being here. Thank you for your partnership.
My
and we
pleasure.
look forward to a lot more to come. Thank you.
Good luck.
All right, thank you. All right, guys, so there you have it. From the toughest cloud environments to the broadest enterprise environments to the most demanding HPC applications, second generation EPYC is incredible. Breadth, scale, capability, we are extraordinarily honored to be turning to EPYC with our customers and our partners. But I want to finish with one important point, okay? We all know in servers, it is not just about one generation. It is not just about 2 generations. It is about building a multi-generational roadmap. And I want to ensure that today it is very clear. We are here celebrating the launch of Rome, and we are extraordinarily excited. But for AMD, we are just getting started in the server market. What you can expect from us is consistency, cadence of execution. You heard it from Marc. We executed first-gen EPYC. We executed second-gen EPYC. With availability today, we have completed the design already on Zen 3, and that is going into Milan. And Marc said it, we are well into design with a ton of design effort on Zen 4 and Genoa. And what we're putting into Zen 3 and Zen 4 and Milan and Genoa is everything that we're learning from the customers and the ecosystem here today. So this is what we mean by commitment. We could not be more committed to this space. We could not be more committed to delivering performance and innovation in the data center. So let me wrap up with one clear message. I hope it is now clear to anybody who is upgrading a data center, building a new data center, doing anything in a data center, whether it's cloud, enterprise, or HPC, you have to use second generation EPYC. It is simply the new standard for data center customers. And I want to say a huge, huge thank you to all of you in the audience today. You are our customers, you are our ecosystem partners, you are the reason we keep pushing the envelope. And together, with your support, we are going to change the data center of today and tomorrow. Thank you very much for joining us today.
Thanks for joining our EPYC Horizon event. Please proceed to your respective breakout rooms. And remember to visit the Transformation Zone and our partner gallery. Check out the demos. Thanks for coming.
That was good. Really good.
HP.com is amazing. Yeah, it sounds really good. Have you seen the HP.com? No. This is your front page now.
Oh, that's great.
HP.com.
You're leaving? I'm going to talk to Leslie for a little bit and then I'll probably come out. Yeah. Really great. Awesome. Well, we'll spend more time following up. Lots of work to do. I gave Leslie some ideas already. I think it's dangerous. Thank you.
So you did. Great event. You can see all the people are streaming out. And I've got to go to the Q&A session. So I'm going to hit stop and I'll talk to you guys later. Hang around because I'll have the Q&A streaming shortly.
Recognize you on the stream. Yeah, good. Sorry, I've hit the wrong button. It's showing me. There you go. So for all those people that are still on, you've got fans. They all recognized you. So, thank you. No worries. Let me hit the button here. Managed to get Wendell on. And, you wanted to see him, so you did. Great event. You can see all the people that are